Saxon's Trig, Lesson 15, Assumptions and Proofs, on page 115. So this is continuing the discussion about proofs, and now we're moving into the formal proofs where, as I've stated before, you're going to have statement and reason column. But before we get into that, in part B, part A is about assumptions and some other terminology that you need. Let me grab this call. All right, so I was talking about the new terminology here, and the new one is theorems, and they are statements that we can prove by using the other things that we've already talked about: definitions, postulates, things that we don't need to prove, we accept on just their general statement. Everyone accepts that is true, and axioms in a deductive reasoning process. So a theorem is basically a rule that we're going to have to prove based on other steps, and it states for you what the 10 postulates are, the statements that we basically accept as truth without having to define them through a statement and reason logic steps to create them as theorems. They are postulates. So here they are. 2 points determine a unique straight line. So if I have 2 dots, I don't need to go through a statement and reason to show you why I can only draw one line. It's kind of like the duh statements. So there is that one. A straight line extends indefinitely in either direction. Yep, we agree with that. A circle may be drawn with any given center, yes, and any given radius. That one's smaller than that one. There's that radius, there's that one. Okay, so a circle can be drawn with a center and a radius. All right angles are equal. This right angle is 90 degrees, so another right angle has to also be 90 degrees. Given a line N and a point P, one and only, oh, I should label that P, one and only there exists in the plane of P and N, and through P, one and only one line M, which does not meet the given line N. Okay, that was wordy. So basically, it's trying to say here that if this is in a plane, inside that plane, I can draw through P, one and only line M. I stuck it on here. The original line was given line N, no, yes, N. Oh goodness, this one is M, this one is N. We're gonna get this labeled correctly here in a second. The original given line is N, and then there is a point P, and it is saying that there is only one line that I can draw through P. We're going to call it M, but that it will never touch this one, because there's only one line that can go through this point that is basically parallel to this one. Oh, very wordy that. Okay, postulate 6, things equal to the same thing are equal to each other. So if I have this line is the same length as this line, then it will be the same length as another line set to the same. All right, if equals are added to equals, the sums are equal. So if I have 2 plus blank equals, and I have, let's make sure I do this right, equals, yes, 2 plus something equals. So if the something that I choose to be the same is a 1 in both places, both answers have to be 3. All right, postulate 8. If equals are subtracted from equals, the remainders are equals. Okay, so if I do 2 minus 1, I get 1. Same thing, I have to get 1. I'm subtracting the same 1. All right, postulate 9. Figures which can be made to coincide are equal. So if I have a triangle drawn, and I can fold my piece of paper and draw another triangle directly on top of it, the one that I've drawn here on the back is going to be identical to this one. Yes, they are So if they line up perfectly, they're going to be equal. And the final one, 10, the whole is greater than any of its parts. Well, yes, if I take this circle and I cut it into 3 pieces, those 3 pieces total to be the full circle. Alrighty, now into our formal proofs. And they remind you in this paragraph on the bottom of 115 that the 3 things that we typically use are side, 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 angle, side. Also, you can list the 3 angles and a side, but that is just the same as basically saying angle, angle, side. And if we have a right triangle, we can use hypotenuse, leg. You can also use leg, leg, they just don't list it. These are the main ones that we tend to use in this book. All right, so on page 116, we have example 1. A median of a triangle is a segment that connects a vertex with the midpoint of the side opposite the vertex. Okay, now that's wordy. So it wants me to prove that the median drawn from the vertex formed by the equal sides of an isosceles triangle bisects the angle at its vertex. So anytime you're coming up on word problems or proofs, they sound really wordy, but you want to break it down individual sentence or piece by piece so that it does make sense. So we need to start by drawing a diagram that we can do some labeling on, so then we can do our statements and reasons. So this should not feel new now because we actually were doing this in the earlier lesson where they just wanted paragraphs of information. So we know that our statement's going to be our given stuff. I just went ahead and filled that in. So let me go back and reread the problem and let's mark things on our diagram. So let's label some corners A, B, and C. A median of a triangle is a segment, line then, that connects the vertex with the midpoint, middle, of the side opposite that vertex. So when I draw that line in, I'm creating a height, and this has to be the midpoint. Well, that tells me if this is the midpoint, this line length and this line length are identical. What else do I know here? Okay, I want to mark what I'm heading to. Prove that the median drawn from the vertex formed by the equal sides, it was an isosceles triangle. So that tells me this side and this side are going to be the same because it's isosceles. 2 sides must be the same length. Prove that the median drawn equal sides of an isosceles triangle bisects the angle at its vertex. So it wants me to show that this angle and this angle, so I'm going to mark them with circles, are the same measurement. That's where I'm headed. All right, so in my given, I know that I was told I have an isosceles triangle. Now in theirs, they list it as they have chosen to label it, and I'm matching what the book was doing. So isosceles triangle ABC, and it definitely is implying, because it said median drawn from equal sides of isosceles triangle bisects the angle at the vertex. No, based on the fact that it is isosceles, I marked AB, segment AB was congruent to segment CB. And again, I'm trying to always line those up in the list in the same order. So because I was given an isosceles triangle, this side and this side were the same. Those were my givens. What else did I learn when I marked this? Well, I said that because this was midpoint, these two were the same, and I marked them. So I want to put that here. We need to label that a D. AD is congruent to CD. And why did I know that? Definition of a midpoint. A midpoint has to hit in the middle. So I can definitely state that those two are the same. Now, how many parts in the triangle do I have at this point? Side and side. What else can I use to get another part? Well, I could possibly talk about these angles, but I don't really have a rule based on just it being a midpoint. Now, I do know that a height is always supposed to form 90 degrees, but I've not proven that rule technically yet, I guess, in this list of what we've proved so far in this book. But I do know that segment BD is the same as segment BD, and that's the same side in both triangles. So that is its identity. It's its own line. So that's the reason why I can definitely say that. Does that give me three pieces, side, side, side? Yes, it does. So I can say that triangle ABD is congruent to triangle CBD. Again, I want to get that same order, Y, side, side, side. And then what did I want to prove? That angle ABD is congruent to angle CBD, Y, CPCTC. So you see why doing the earlier proofs in this statement reason makes this feel like it's really basic and simple and follows that same pattern over and over and over. The other thing is I used identity to state that these were the same. They used the term reflexive axiom, and that's why they had that term at the beginning where it said axioms. It doesn't really matter which one you use. They're being the more formal. I'm kind of using just the fact that it is its own thing, therefore it's its identity. Either way that you choose to do it is okay. All right. Oh, I omitted one other thing that they did, and it is probably really important to actually have inserted it in here after my givens. We drew this line BD in. It was technically not a part of what they told me originally, which was that I had only an isosceles triangle. And so I should have stated here in 2 that I'm going to draw a median BD connecting to side AC. And that's what they're putting there in their step 2. And that they used as technically part of their given. It's kind of how I accidentally omitted it, but it should be stated in there that BD was inserted into the shape as part of the givens. All right, example 2. Prove that if 2 tangents to a circle, I'm definitely not, no, I definitely do not have room to do all of that there. Let's just draw the picture on the next page. So I have a circle, I'm told, and 2 tangents to the circle. Tangent here, and prove that 2 tangents to a circle intersect at a point outside of the circle, then the lengths of the tangent segments are equal. They want me to ultimately prove that this and this are the same. Now, I do need a center here, and I need some things labeled. So just to match what they have, this was a B, they labeled this one O, they labeled this one A, and this point here, P. Okay, now, before I can do my proof, I know that I need triangles, and I don't really have that. So we're gonna work on that here in a moment. Statements and reasons. Obviously, our number 1 is going to be what we were given. So we are going to state here that AP, yes, I am going to state that as a segment. So segment AP and BP segment are tangents, because it told me that. In theirs, they listed that O was the center. How precise do you need to get? With me, not overly precise. If you're trying to do a formal proof on a standardized test, you probably want to list literally everything that you put in your diagram. So somebody who's reading your statements and reasons will know what's happening. So they're going to say that O is the center. That's part of their given. And they also stated that A and B are part of those. You're always going to have a picture that's showing with your statement reasons. I don't know that it's really as critical to say that A and B are a part of that tangent line, but that is what they're doing there. So then in step 2, I want to be creating the triangles. So I'm going to connect the radius here and the radius here as part of getting my 2 triangles. So I've got OA and OB segments are radii. My reasoning there is, oh yeah, I love their formality in theirs. So it says here they're saying draw radii, so we'll attach their draw. So we're drawing in those pieces and segment OP because I need to get the 2 triangles to be formed. And so we'll say draw O segment OP. And then their reasoning here was 2 points determine a unique straight line, which is Euclid's first postulate. Now, would you have all of these postulates memorized? No. Would you know that it's Euclid's postulate? Probably not. Do you want to look it up in the back of the book where there is a list of all the postulates and theorems? No, you really don't. So basically, you're going to say draw lines with 2 points. Anything that's basically giving you a reason for why you're doing what you're doing. All right, so now I have my 2 triangles. What can I state are the same things? Well, if this is a radius, AO, it has to be congruent to the other radius, BO. Why are those segments the same? Because they're both radii. They have to be the same length for that same circle, radii of circle, perhaps. Something along that line. They said, oh, they're doing something. Again, the order that you do does not really matter as long as you're getting to your 3 parts. So I may not always match exactly the order that they show in the book. Your order will probably not match mine. All right, so I've now gotten this side and this side are marked as the same. I can get a second side by saying that OP is congruent to OP. Again, that's identity, or their extra wordiness if you prefer. So that gives me 2 sides. And I know that I've drawn a radii to a tangent. So we knew that there was a rule with that. And that is that angle OAP will be is 90 degrees or right, however you want to put that. And the same rule applies for the other one, which would be OBP is 90 degrees. Why can I say that for both of those? Well, that's the definition of radii, either way, definition of radius and tangent. They have to form 90 degrees when you connect a radius to a tangent. That's one of those original rules that we gave you. Now, do we have 3 parts for our triangles? Yes, we do. So triangle APO is congruent to triangle BPO. Again, keeping that same order. What were the 3 parts in order? Side, side, angle. Side, side, angle. All right. And then final step, segment AP has to be congruent to segment BP. Why? Because of CPCTC. And we've done the proof they wanted. Example 3. Prove that the sum of the measures of an angle of a triangle are 180 degrees. So we have a triangle. We still have our statements and reasons. And our first is obviously going to be the given. Let's label these A, B, and C. So my first given is that I have triangle A, B, C. It's not isosceles or anything special. And we're proving that so I can't really mark that all three angles are 180. I can't mark that. However, I'm going to hold it in the back of my head as I'm working here. So you would not instinctively know this without seeing this given to you this way. That's why we're going over some of these examples so that you will begin to get a feel for, oh, this is what I should do in this situation. Not that you were expected to immediately know this without being shown it first. So I'm going to also, in step 2, I'm going to draw a parallel line through B. And this will be parallel to this, parallel to segment AC. I guess I should be really, really clear. And so you can use here construct. That's okay because you're actually constructing it to be parallel. You're not going through 2 points, so you're not really using that line, but that would be okay. Then in 3, seeing if I'm going totally out of order with that. Yeah, pretty much. I need to start labeling some angles here. So let's label this one 1, this one 2, this one 3. Once I've drawn this parallel, can I label this angle 1 in any other place? Well, if you picture this as extended line, it's just easier to see it as our parallel and our transversal. Again, I'm going to kind of extend that line as well. So is it okay to say that this up here is 1? Are they alternate interiors? Yes. So the reason here is they are alternate interior angles is why I'm allowed to say that angle, and I can't use the B because it's B is marking all 3 of those places. And I don't want to be confusing. I could choose to label another dot here. They're not even getting that formal, and usually they're formal about everything. So what I'm going to do is I'm going to actually state here angle A is congruent to angle 1. Even though this is labeled as 1, that way you can see the difference that I'm heading toward. Alternate interior angles. Can I do the same thing with angle C is congruent to angle? Yes. 3 can be marked up here because of alternate interior, because this is also a transversal. Okay, now in this step, angle 1 plus angle 2 plus angle 3 forms a line. So they must equal 180 degrees. That's the definition of a line. Then in the next step, we could do some substitution and say, instead of 1, 2, and 3 here, we can say angle A instead of 1 plus angle 2, no substitution there, plus, and instead of 3, angle C equals 180 degrees. Why? Substitution. And that is what they wanted me to prove. The 3 angles inside the triangle form 180 degrees. Okay, example 4. Use the 6th and 8th postulates of Euclid to prove that vertical angles are equal in measure. Now, they're telling you this because they want to kind of shorten it. However, do you know what the 6th and 8th postulates are without being told? No, not really. All right, so this is again a case of you want to see how this works so that you kind of get the feel for what you're supposed to be doing. So we know that we have vertical angles and we're trying to prove that they are the same. They also, no, they did not. Okay. Again, I don't instinctively know unless I sort of know how this proof is supposed to go. I need to pick up two of these vertical angles and say that they are given as verticals. So let's do angle A and angle C are vertical. That's what's been given to me. I feel like I didn't spell it right. No, I didn't. A-L, that looks better, vertical. Okay, that's my given. So I can see, based on this picture, that the measure of angle A, because now I'm not talking about where it's located, I'm talking about how many degrees it is. So the measure of angle A plus the measure of angle B forms a line, equals 180 degrees. How do I know that? Definition of a straight line. I don't have to clarify straight, the line should be straight, so definition of a line. Same thing can be stating here, the measure of angle D plus the measure of angle C is 180 degrees. Now, if I have these two are equaling the same thing, I can state with substitution that the, and this is going to be much longer, measure of angle A plus the measure of angle B equals the measure of angle D plus the measure of angle C. So instead of making them equal to 180, I'm equaling them to each other. Can I state, oh yeah, that's Euclid's sixth postulate, that things that are equal to the same thing, it's just easier, again, to say substitution there than to use the sixth postulate. So if I can subtract the same thing, which is Euclid's eighth postulate, so this is kind of trying to refer to those postulates there at the very beginning, and Euclid is the one who came up with these as the does statements. So I feel like they fudge just a touch here because they want you to prove that A and C are the same if they're vertical, but they use the fact that B and D are the same in order to subtract them off, which leaves you with the measure of angle A equals the measure of angle C, and then they said I subtracted the same thing. So I would say subtract equal degrees, anything along that line that explains what you're doing. And that is what they wanted me to prove. Or you can say Euclid's eighth postulate if you so choose. It's like I said, then they say at the very end of this proof, you can do the same thing to prove that B and D are the same. Although, like I said, I have a bit of an issue with they're using the vertical to prove the vertical. All right, example 5 asks you to prove, this is more in the actual, not paragraph given information, but in the way most of the proofs usually look. So they usually give you a diagram, so you're not creating it yourself. C, and they give you this to D, which is very helpful. And you will want to probably copy the picture onto your page as you're doing it so you can do the markings. You don't want to do that physically in your book. We know we're going to have our statement and our reason titles. We know that one is going to be given. And then they also provide the given. So they say segment BD is the angle bisector of B, is angle B bisector. That means this side and this side have to be the same in measurement. And they tell me that segment AB is congruent to CB, so I can mark this side and this side as the same. So they're giving me two of the pieces. And then it says, write a 2-column proof to show AD, so that's this side, matches with CD, this side. So now I know where I'm headed. If they've given me two of the parts, can I find a third piece? Oh, well, I usually look for identities. Oh, before I do that though, I marked something on this picture that is not here in my given. It states that it bisects it, but I need to put in my proof what that means. So we need to say that angle ABD is congruent to angle CBD because that's the definition of bisect. Students will often ask, how do I know where I'm headed? I said I want to look at my diagram and I'm looking for those three pieces. I also want to go based off of what I just had. So if reading something allowed me to mark it, I need to make sure I have it in my proof. Now I can move on to the third piece, which is that segment BD is the same as segment BD, identity. And now I have three pieces. So the triangle ABD is congruent to triangle CBD. What are my three pieces? Side, angle, side. And again, I want to get them in order without jumping around. And if I have congruent triangles, then segment AD can be congruent to segment CD because of CPCTC. So you get the idea of why I said you're going to use that a lot. Example 6 is the final one here. And again, we are given the picture, so we want to put it on our paper. And they're marking that this is parallel to this. And we'll start with our given. What did they actually give us to write? That angle Q is congruent to angle S, and I did not label their P, Q, R, and S. So Q and S are the same, marked. And they also told me that PQ is parallel to SR, which I knew from the marking of their picture with the arrows, but they're stating it in our given. Okay. Now, where are we going? Write a 2-column proof to show that triangle PQR, oh, forgot this line, triangle PQR is congruent to RSP. All right, so here are the two triangles. I've only been provided with one angle that is the same. I can get a second piece by saying that PR is congruent to itself, identity. So now I have an angle and a side, but they're kind of opposite each other. I need a connecting piece like angle side, side, but I have no way to say that just because these are parallel, they're the same length. I could do angle side, side, but again, I don't know a rule that tells me those two are the same. But if these are parallel, this is acting as a transversal, so I know I can use alternate angles. So that's probably where we need to go. So let's pull this one, and what would its alternate interior, because here are the parallels, would be this side over here. So let's list that. Angle QPR is congruent to angle, let's see, P had the marking of the two, so in order that would be RSP, and that's because their alternate interior angles have to be the same. Do I have my three pieces? Angle, angle, side. Yes, okay, so triangle PQR is congruent to triangle RSP, and that was because of angle, angle, side, or side, angle, angle, doesn't really matter, whichever way you wish to write it. And I don't need a CP/CTC on this one because what it wanted me to prove was that the two were congruent.